This is Mr. Beck Does Your Homework, AP Physics, Homework 9.2, questions 6 and 7. Question 6 says, two charged particles of equal magnitude, plus q and minus q, are fixed at opposite corners of a square lying in a plane. A test charge plus little q is placed at a third corner. What is the direction of the force on the test charge due to the two other charges? So I've got this charge, I've got this one, and what this is asking is, what direction will it overall feel a force? So you've got to say, well, a positive and a positive, what's that going to do to this one? A positive and a negative, what's that going to do to that one? And you're going to wind up with two different arrows, and what you've got to do is figure out what direction those arrows would point when you add them together in a vector fashion. So if you wound up with an arrow up and over, that would vector add to an arrow up in that direction. So I'm not telling you what the answer is, but you have to figure out from pluses and minuses and attracting and repelling. But question number 7 says, let the side of the square be A. So I know that this is a distance A and this is a distance A. And so my R, my radius, is going to equal A. What is the magnitude of the electric field at the location of plus Q due to the two charges plus Q and minus Q? I know that the electric field strength due to one of them is going to be K times big Q divided by little a squared. But if I want to vector add these two charges, this is going to be the length of one side of the electric field vector. I'll get the same magnitude in the other side. So it's looking for magnitudes, so I can just make them all the same. So I've got a magnitude, and I have to find the hypotenuse. Well, I know that if this squared plus this squared equals this squared, then this length will be this length times radical 2. So I know that whatever this electric field is, that the resulting electric field up at an angle is going to be this electric field times radical 2. So if I do E times the square root of 2, that's going to give me the resulting electric field from my E vector. I'll draw a little arrow meaning this vector, plus my other electric field vector. So when I do that on a triangle, a right triangle, if this were 1 and this were 1, then this side would be square root of 2, because 1 squared plus 1 squared is 2. Square root of 2 would be and this is if I'm at a 45-degree angle. So this is going to be radical 2 times whatever the side is. So this side will be the strength of the E field from one of them. So this resulting vector, whichever direction it points, is going to have sides that are this big. So it's just going to be 2 times the E, and the E is that. So you can pick your multiple choice from that selection.